Hi and welcome to the second lesson. So this is basically where we left off. We had one cube in the middle of the scene and we were rotating it. Press play and the cube will start rotating. We had also the values here, so we could actually change them on the fly and see it run. So this was a quite nice thing to have. We are able to do something, to show something on the screen, but what would be really interesting is actually interacting with our objects. For example, let's have let's change the color of our cube when we click on it. So for interaction with game objects, the important part is to have a collider on top of them. So if you go to scene, we select the cube, you see this is our cube. If we make this 1.25, you see there is also a green cube around it. That is our collider. This is what we will interact with actually. Not the cube, but with the collider that fits really nicely on top of our cube. How are we going to do that? Unity helps with that. On mouse down, which means when you click on something, you can actually interact with it. For this, we need to create a new folder, materials, and create a new material. So we're going to call it white, because that's what it is. All it does is a white color. We can change the color, nothing happens on our cube. For this to actually change, we actually need to drag it on top of it. And now it's here. We can change the color to red. And if we select here, it has changed it. And if you change to white, it changed the one that is on the cube. So now we have our new material present on the cube. As you can see, the material is part of an array of materials, which is part of Mesh Renderer. So all these scripts here are components of the object. So what we're actually going to do is we're going to look for those components and then we're going to interact with them. So what we need is the mesh renderer. Render equals, and for that, if your class is mono behavior, you can use get component. You can also have in children or in parent. This we will look afterwards. You can also get all the components that fit what you're looking for. And we are looking for the mesh renderer. And we save it like that. Okay, we have our render. What can we do with it? Well, we need to get the material from him. Material, and as you can see, we have the material itself, and we have our array of materials. So we only have one, so we take the first one, and we want to change the color. We have two ways to change the color. There are predefined colors that we can use from the class. So I can show like this: blue, black, clear, cyan, gray, green. But if we don't want that, we can actually make our own new color. So you can make an empty one without setting the values. You can set the RGB values, red, green, and blue. And you can also do RGBA, where you set the alpha. So here alpha is always going to be 1. This is the one we're going to take. These are floats, which means that they are from 0 to 1. And now our color will be red when we click on our cube. Wait for script to compile. We press play. And when we click it, it's red. But after that, if we click again, nothing is happening. What are we going to do? Well, let's say we only want it to be red when we click on it. Once we let go, it should be all white again. And that's exactly what we're going to do. I'm clicking, I'm pressing, and when I let go, it goes back to white. So we can now interact with our cube. So now what we're going to do is we're going to stop it from turning around, and we only keep the color change. What we're actually going to look for now is we want to move our cube around. So how do we move our cube around? Let's say we want to go forward if we press the up arrow. So if input dot key up, so here it already tells me that it requires a key code, and it's the up arrow. So when the up arrow is there, I want to do something. If input dot get key up, key code dot down arrow, we will also do the opposite here. So what do we need to do here? It's quite easy. We want to change our position. Our position is a vector 3. We're going to call it position, and it's part of our transform. And we take position. You can see there are two different positions here. Position itself is in world space, and local position is relative to the parent. We haven't looked into parents and children yet, so I will just work with the regular position. And we want, for example, it would be nicer if I would actually write properly. Position. We want the X value, for example, to increase by 1. So now we change by 1 our position, but we still need to save it back into our transform. We take this and minus equals 1. What this is the same as so these are the same. So plus equals means that you're going to add this value to this. Oh yes, so dot x here. There we go, like this. these are identical. So we take the X value of our position, we do +1, and we save it in X. This is what we're doing with plus equals, and the opposite is minus equals. So now when we press our key, it will go 1 forward. If we press the down arrow, it will go 1 backwards. Let's go test it out. I'm pressing it, and as you can see, it works. But if I keep pressing, nothing happens. So we use key up. What we can also do is use key down. So key up is when the key goes up, key down is when you actually press. So now what we actually want is our cube to keep moving, not to stop. And definitely we want a fluid movement. So how are we going to handle that? It's very simple. We actually need to save when we are moving and in what direction. So we need a boolean for this. Call it moving forward equals false. And public bool moving backwards equals false. So we start without moving at all. I make them public. This is mainly in the tutorial because we get to see them here and we can actually press and test things out without the need for keyboard interaction also. So we're going to remove this and do Ctrl X and say if we're moving forward, then you execute this code. It is that simple. This will be the same. If you're moving backwards, you will execute this code. Note that it's interesting to know that there is a difference between putting this first or these ones first. Like what happens basically is if you put these first, the frame, I'm going to show you. And here we set moving forward equals true. And then so if our key went down, we are moving forward. If it goes up, we stop moving forward. And if we put this here, that means in the frame I press down, it will already execute this. If this is underneath it, it will actually wait the next frame before reaching this code. Small details, but always good to know. So if I press play, I'm going forward. And I'm losing it. So I can bring it back. And I'm going forward. Now it's a bit fast. What I would like to do, and how it usually goes, is I want this to be time-based. So what are we going to do first is we're going to set our backwards walking also. Input dot key up key code dot down arrow underscore moving backwards equals false. So now we have our boat movements. We can do this time-based. For example, there is time dot delta time. So time in seconds it took to complete the last frame. So this means that we will move one forward per second. And we're going to move one backwards per second also. So if we have 60 frames per second, this update is called 60 times. And this will be 1/60th of a second. So now we already have very fluid movement. If I press up, of course I pressed the play button twice. I am moving forward slowly and backward slowly also. And you can check on the cube here that when I press it down, it actually changes the values here. So now what do I want? I would like some speed. So how am I going to do that? Well, it's very easy. Take a float because I can tweak it easier if it's a float and not an integer. And I'm going to call it movement speed. And we're going to start at 1, for example. What does this mean? Is we replace our speed here with our movement speed. We go back here, we check the cube, and we see our movement speed 1. And let's make it 5, for example, now. Well, of course, when you stop playing, it's okay. I'm going to put it to 5. And now we have already a better speed. Let's say we can also, because it's a float, we can actually tweak a lot nicer. If we press both, we're not moving, which is also interesting to know because we're moving forward and backwards at the same time. So there is no, we're not excluding moving forward and backwards at the same time. I let go at one or the other. All of that is possible. So this is our basic input. Now, what we're doing is we are moving forward based on time. What we can do also is our transform also has a vector which is forward. So what does this mean? Is instead of changing our x values, we're going to change our forward vector. I'm going to go back here. I'm going to write transform dot. Of course, here it doesn't work because of this issue. So the blue axis of the transform in world space. So blue axis in the transform. So this is the blue axis in the world space. So actually, this is how we're going to move forward. And we are setting that. Okay, now we're taking this. Yes. Let's take this. And now we do the same here. So we are still moving forward or backwards because of the minus. This is not backwards, so this is forward, there's up, and I think, if I'm not mistaken, there's a right. And so right, the opposite of right is minus right, of course. So now what happens now is, yes, we forgot to remove the x. So now we use a forward vector. So now he's moving forward like that. Speed is 1, let's go to 5. But what happens if I rotate it? All of a sudden his forward is different. What does this actually mean for me? Well, first of all, I would maybe want to change, yes, these ones. So we're going to change the y-axis. How are we going to do that? We're going to make a couple of booleans more. So we're going to have turning right, and we're going to have turning left. We will have, yes, this is, oh no, key down, key up, yes, sorry about that. We're going to take this, key down, key up, and we're going to have left arrow. Left arrow is going to be turning left. And we're going to do the same with our right arrow. It's going to be us turning right. So we now have the ability to turn. We are turning, which means that if you are turning left, we want to take our vector 3. Well, actually no. I'm going to transform dot rotate and minus rotation. If I'm not mistaken, this should turn us left, and for turning right, we are going to rotate our rotation. So if you press the right arrow, we will be turning. We go back to our cube. we set the Y speed 5, and we are going to rotate. If we turn, we are rotating. And this means that we can also move around now. Now, as you can see, our rotation is quite fast, but that is not an issue because at the same time, we can multiply it by delta time. So vectors can be multiplied by a single value. This means that instead of turning for 5 degrees while pressing every tick, we are now going to have a very slow movement. So let's go to 90. And we can turn around. Much nicer. And here we have a moving character. We can move a character around on the screen. It is that easy. If it was a real character, now I would have something like waving at us, but that's not possible with a cube. But here you go. So this was it for basic inputs. So what did we learn? We learned that we can click on our cube. You see the script is still there. The information is still there. So we can click on our cube. We can interact with it. We could have, for example, other objects on the scene. And we could interact by clicking on them. We also learned how to move around. So that's another one. Quite interesting. And not only are we moving around, but we are doing it frame independent. So you will, no matter how fast your computer, you will always move at the same movement speed per second. So this is also very interesting to know. Also notice that the values don't change here. So that's important to know for Unity. Script values are overwritten by the prefab. So we have 90 here, 5 here. These are the values that will be used and not the 1 and the 500 here. So this means that in your game object you can make changes in your scene, and that is actually what it's going to use. But this was it for basic input, usage, mouse clicking, and also a short look into how to change colors and interact with our environment. I hope this was useful. Lasted a bit longer than expected. It's like a half an hour. But yes, if you have any questions, put it in the comments. At some point I will add a lot of information, so that might already be there in the comments, so how to contact me. And I hope you enjoyed it. And I missed something, let's make sure. So we can go through the script again, just to be sure. So we still have our rotation, even if we're not using it anymore. So we have a specific movement speed at which we're going to walk fast. We're keeping track of how our movement is going, which movement we are doing. So here are, if a key goes up or down, we are actually keeping track of what to do in that specific thing. So we press the up arrow, we start moving forward, we stop pressing, we start moving forward, we stop pressing it, we stop moving forward. And we do that for all the keys. Afterwards, this is what we're actually doing with the code. There are a lot of ways how to optimize this. This is not important at the moment. what is important. So we take our position, we add our forward vector multiplied by our movement speed multiplied by delta time, so the time between each frame, and then we set it back. So, and we do the same when moving backwards, except minus forward, and so we're walking backwards. On the mouse click, we can now get components out of a game object. I would suggest something interesting is actually make sure that the component exists before trying to interact with it. Because if the component does not exist, you will get null pointer and it can cause your game to crash, which is something that you should avoid at all time. So you can do it like this, because this is a mono behavior. To know what it exactly is doing is this is what it's actually doing. It's checking if the render is not null, I can actually interact with it. A good option would be to also check the material, if the material exists. So we can add it here. So if our render is not null, our mesh renderer, and the material of the mesh renderer is not null, we actually change the color of that specific material to be this one. So I hope this was helpful. Went to a bit past a half hour now, but this was a short overview on what we did today.